Hello. Ooh, I'm hot. Welcome to our evening session. It's going to be exciting. I'm feeling warmer already. Our speaker tonight is Lycklama, and I'll read this again for those that weren't here this morning. He earned his bachelor degree in engineering and physics and a PhD in experimental nuclear physics from McMaster University in Canada. Since then, he has worked with telecommunications and computer software. In 1992, he formed the Open System Technical Association and helped technical support for other services. And then in 2013, he founded the Apologetics Forum to help equip believers in the defense of the faith. When his kids were going through secular school, he was bombarded with evolution versus creation. It really sparked his interest, and he was drawn to that and researched the whole debate with creation versus evolution. Then as his kids were going through school, they kept asking questions, and so he got more research that helped them to understand their faith. And so it's been a challenge and for him for a long time. So he and his wife live in Arlington, Washington, and they were born in the Netherlands and migrated to Canada after World War II. And then in 1964, they were married and immigrated to the United States. They have 5 kids and 16 grandchildren. And their wife, Gerda, and one daughter, Wendy, are here with us tonight. So welcome, Heinz.
Thank you. Thank you again. How many here like science? Good. Because I'm going to talk a little bit science, but I'm going to do it at a low level as I can, because I'm not going to go into equations or anything like that, but you'll get the idea. And so let me just open a word of prayer and we'll get started. Father, we come to you just to thank you for this time. We thank you for the folk here. Pray that you would give me the words to use that people could understand, Lord. And you created this world, and you allowed us to study your world, what you created, and we see the evidence for that, Lord, and we see that it supports your word, and we thank you for that. In Jesus' name we pray. Amen. So I'm going to go through this presentation. The way I do things is some people call it's the Russian way of presentation. Tell them what you're going to tell them what you told them. Okay? So here's what I'm going to talk about. This is what I'm going to tell you. First of all, what is the biblical mandate as far as we're concerned as stewards of the earth? And then what is global warming and climate change? I use those two words interchangeably because the people that study this changed it from global warming because it was warming, and then when it got cooler, they had introduced the other direction too. So it's as if somebody controls this cycle. So climate change. Do we have a climate crisis? Is the topic here. And what are we talking about? Greenhouse gases that impact our climate. We'll talk about the gases and also the effect of those. And then there are 2 organizations that are relevant. First of all, it's the UN, IPCC, which is the Intergovernmental Panel on Climate Change. And those are the people that study climate. And most of the countries in the world are involved in that study. And then the other organization is called the NIPCC, which is the non-governmental International Panel on Climate Change. And these are scientists, mostly in the U.S., but also other countries. So it's only scientists, and they study the science of climate change and have a different opinion than the UN IPCC has, and I'll explain why. And then I'm going to go through 16 different key issues that impact the climate that we have. And then we'll look at the actually the benefits of warming and more CO2 in the atmosphere. And then we'll ask the question, what do some of these other experts say about the climate? What controls the climate? And then draw a conclusion. So with that, first of all, what is the biblical mandate? In Genesis 1:28, we are to be fruitful and multiply, fill the earth and subdue it, and have dominion over the fish of the sea, or the birds of the heavens, and every living thing that moves on the earth. That's right in chapter 1 of Genesis. We are to be stewards of what we're given. Let's see, I skipped over a few. Okay. So, and then the next verse, which is important, Genesis 8:22, while the earth remains, seed time and harvest, cold and heat, summer and winter, day and night shall not cease. In other words, we will always have seasons, we all have warming, we will always have cooling, but God is in control of that. And then as a scientist, as I said this morning, we are to test everything. You know, we don't just take whatever they tell us and say, yep, that's true. We are to test it all and make sure that it is good and true. So what are some of the claims that the UN IPCC is making? That's the intergovernmental panel there. So the global warming, they say, is occurring at a very rapid rate. Now, if we don't stop what we're doing, you know, we're going to be toast. We're going to be out of control. Largely due to increased burning of fossil fuel, and that's where carbon dioxide comes in, because fossil fuels give off carbon dioxide into the atmosphere and say that's what controls our climate. We must cut back on the CO2 released into the atmosphere. Like I said, these are representatives of 190 different countries. They meet once a year. There are 6 reports that they've come out with over the last 30 years. They're issued every 5 or 6 years. And then the claims that the UN IPCC people make are refuted by this other organization, which is the Non-Governmental International Panel on Climate Change. And I have followed that group from the beginning. When I stopped my consulting in the computer industry, I started to look at some of these issues, like global warming. And so I studied this for about 4 or 5 months and came to the conclusion that the UN IPCC is not telling us everything. They're not telling us the truth, and you'll see why as we get into it. So then, what are some of their claims? These are the predictions by the UN IPCC. We'll have 5 degrees warming, and that's in centigrade, by 2100 if we don't do something about controlling our climate. The Arctic ice cap will disappear. Polar bear population will decline. Sea level will rise by 88 centimeters, which are a number of feet, by 2100. There will be increased droughts, extreme weather situations, more storms, heat waves, and more wildfires, and the most significant threat to mankind. It's the most important thing that we need to worry about, and so we must act now. Okay, and this is going all the way back to the 1990s. So we're going to look at what is the reality. Okay, you may, for some of the older folks, you may recognize back in the 70s, you know, our weather, our climate really was going down, where we were cooling. And so there was a warning put out by some scientists or more politicians who said, if we don't do something, we're in trouble. We're going to freeze to death if we don't do something. Well, we lived up in Canada, my wife and I, at that time, and I know we had very deep snowbanks back then when it was cooling, and it really was cooling. But now we have an upward trend, and that started in the late 70s and early 1980s. And so now, 2000, 2006, 2008 there, warned that we don't do something, we're going to be really hot here. So it's really warming. So these are two different warnings, and they were put out by the same. If you look at the top line there, climate change alarmist included Governor Brown from California, and there's a scientist, John Holdren, who were the ones that warned about cooling in the 1970s. Okay, the same people in 1980 warned about warming. So which is it, you know? And here's some more of the facts behind it. Governor Jerry Brown, 1977, global cooling. I won't tell you what BS stands for, or recycled by Jerry Brown again in the late, into the next 10 years. But it's the same governor because he had 2 times that he was a governor. And let's see, yeah, and John Holdren, he was a scientist, and he was a part of Obama's government later on too. So he had 2 different views. First was he was concerned about cooling, and then he was concerned about warming. This guy, you know, he's the leader of this effort. He says back in 2008, the entire North polarized cap will disappear in 5 years. Al Gore in 2008. Did it disappear? No. You know, we're now 2025, and I'll show you some pictures of the Arctic later on. Okay, what is the cause of the climate? Well, obviously, our power comes from the sun. That is our source of power. If we didn't have the sun, the Earth would be like the moon, just dead. Nothing, nobody could live there. But the point is, scientists have figured out how many watts of power per square meter come down from the sun, and how many are reflected off the clouds, and how many hit the Earth and warm the Earth, and are reflected by the water, and reflected by the Earth itself. And so they can measure those things. And to be balanced, you know, that is what you want. And then you have a steady climate. So that's the greenhouse gases determine how much is reflected out and how much gets down to the Earth. And I'll get into the greenhouse gases next. Okay, well, here they are. And you'll notice that there's some numbers on there. The percentage of all greenhouse gases, the largest number there you see is water vapor. Think clouds and water vapor. That's 95% of the greenhouse gas. And then the carbon dioxide is 3.618%. And then the others of note are methane. You might have heard about methane. And then nitrous oxide, which is used in fertilizers. So those are the percentages of greenhouse gases in the atmosphere. But if you look at break it down into what's natural, what's always there without man being there, the impact that man has is very, very small. So like for water vapor, there's nothing we can do. I mean, the Earth is covered by 70% by water. So there's nothing that we could do to change that. But we do have some impact on carbon dioxide. So we have but just a 0.117 out of that 3.618. And then methane is about a factor of 10 less than carbon dioxide, and then nitrous oxide. So those are the gases. And so man-made is only 0.28% of the total greenhouse gases. And they said man is the one that is causing the trouble. Okay, that's the first fallacy. So, okay, and here's another look at it. Those percentages, you see on the right there, there's a little green there of all the gases or the carbon dioxide in the atmosphere. Man is only controlling about 3% of that. So we don't control the amount of carbon dioxide in the atmosphere in total. Yes, it is increasing, some of it is due to what man is doing, burning fossil fuels, but we don't control it. The biggest factor is the water vapor and the clouds. Okay, just so remember that. So now I'm going to walk through these 16 different issues that I looked at. And by the way, I started to look at it back in 2009, 2010. And I wrote up my conclusions and I sent them to the UN IPCC, the leaders of that. And they didn't like what I wrote. In fact, one said, if you send me another message, I'm going to sue you. So I took them off my mailing list. But anyway, they don't listen because they've made up their mind. So if you look at the history over the 2,000 years or 4,000 years, you can see the ups and downs. The orange is when it was above average, and blue is when it was in a cold phase. So we've gone through ups and downs. People may remember the medieval time when Greenland was green, right? And now it's not green. So there are changes going on. But the last blue one there is in the 1800s, 1800s, and that's when we had some real cold weather. The Thames River in London was always frozen over. It doesn't always freeze over anymore. And so we're coming out of that, and you can see the small orange pieces that we're going through. And by the way, again, all of these slides are on my website, so I can't cover everything in this slide. And if you want to study that, just go to my website, which I'll show you, and then you can look at that in detail. Second, people have to realize that carbon dioxide is required for life. If we didn't have carbon dioxide, we wouldn't have life. If carbon dioxide was less than, about 150 per million, 150 parts in a million, nothing could live. We need some carbon dioxide. And so we're now at 420 parts per million carbon dioxide in the atmosphere. Sometimes you hear the politicians say, well, we got to get rid of these carbon dioxide pollutants that we're emitting into the atmosphere. And yes, there are some bad gases that we emit into the atmosphere, but they are removed. Most of them have been removed, but the carbon dioxide itself is not a pollutant. Life needs that. And in fact, you'll see later, carbon dioxide increases food production. The more carbon dioxide we have in there, the more food grows. So first of all, C2 is not a pollutant. Even our breath, we emit some carbon dioxide, very little bit, but we do emit it. And of course, the power plants, they do emit carbon dioxide. And of course, driving your car, we emit carbon dioxide as well. And here's one example of parts per million. We are now at about 420 parts per million. And so we're closer to the 385. But if we add, the more carbon dioxide we add to the atmosphere, the bigger the plants grow. Okay, and you'll see more of that later on. Issue number 3, Al Gore says, you shouldn't argue with me, the science has been settled. Well, it's not settled. Here were some predictions by, again, John Holdren, Obama's science advisor. And these were made in 1970s and 1980s about global cooling. But everything that they have projected, Al Gore, John Holdren, they've come to naught. The UN overestimated global warming. I'll show you the results of their models. They're not correct. Rainforest species will become extinct. Oil will run out by 2015. Anybody still using oil? Still here. Arctic sea ice will disappear by 2015. Well, I'll show you a picture that's still here. And looking in the future, 1 billion people could die from climate change by 2020. Well, we're 2025, so that didn't happen. And then Holdren, again, in 1971 said, a new ice age is very likely. Well, that didn't happen. And here are some other pronouncements that are made. I'm not going to read them all. You know, the last one there is science is settled, and you know, the polar bears will become extinct and all that. Well, those things didn't happen. But if you want to look at the slides, just download them, and you can read all that. We have had some cooling, and I show you there a graph between how much we are emitting into the atmosphere over time. And yes, we are emitting more from the coal, from oil and gas that we use to fuel our cars and other things. But you'll see there in the 60s, 70s, the blue curve there is the temperature, and the solar activity is in red there. And you'll notice that those two follow pretty well. So this is one example where, you know, the sun obviously takes a big part in climate change. And this is another one going back to zero, time of Christ up till now, roughly. You know, you can see the medieval warm period. Back after the time of Christ, there was a Roman warm period as well. And now we are roughly in a modern warm period, but we're not as warm as it was in the medieval time. Okay. Whoops. Okay, this is an interesting curve. Michael Mann, you wouldn't have heard of him, but he's one of the members of the UN IPC, and he is the one that had made huge claims that if we don't do something right away, we're toast. And then he shows that picture up above where the climate says, well, it was pretty stable for you know, a long period of time there, somewhere 1,000 years, and then all of a sudden this hockey stick curve. Well, then there's another a real climate scientist, Tim Ball, who's been studying climate change for 50 years or so up in Canada. He draws a more accurate picture of a history of the weather and of the temperature. And so they obviously don't match, they don't agree with each other. And that was a problem. So then we have the NIPCC, which is the non-governmental international panel on climate change. And this is comprised of scientists and scholars who study this, not other people, it's all scientists. And they have peer-reviewed technical papers that are published. They have an annual conference to discuss what they are finding. And they came up with these articles and these books. Nature, not human activity, rules the climate, is the conclusion they made. So totally different from the UN IPC. Climate change, reconsidered 1 and 2, scientific critique of the IPCC summary, and another article, actually a book, which says why scientists disagree about global warming. So number 4, CO2 cannot drive global warming by itself. And it does have some impact on global warming, but it's not what the UN IPC warns us. And I'll explain why here. So first of all, possible global warming causes. What causes global warming? Well, increased CO2 in the atmosphere does increase it somewhat. But how it does that, I'll get into. It's an insignificant greenhouse gas, that's GHG, greenhouse gas. And it follows global warming rather than causes it a lot. Well, we can have global warming by sunspots only. The influence of the sun by itself is minimal, and that's not the major cause. But there are things having to do with cloud cover. Remember clouds and water vapor? That's a big greenhouse gas. That has the biggest impact on the average temperature. Okay, and then the other one that has a big impact is the what's called the Pacific Decadal Oscillation, and that is the changes of the temperature in the oceans in the world. I mean, the world is covered by 70% water. We got the Pacific Ocean and the Atlantic Ocean, and they also go through 30-year cycles, as you'll see. And so they have some impact on the climate. And here's another one which shows the amount of carbon dioxide in the atmosphere. That red line, you know, going back for quite a few years then and up till today. It started in the before the industrial period, around 280 parts per million. We're now at 420 parts per million, and you can see that red. You know, it goes up in a pretty steady way, and it's determined by the seasons as well, when it's stronger or weaker. But anyway, it goes up in a line there. But you'll see the temperature doesn't always follow that line. The first part, for example, is negative. The temperature is going down, and yet the amount of carbon dioxide in the atmosphere is going up. So that shows that it's not carbon dioxide that makes the most change. Oops. Okay, this is a very important chart. So carbon dioxide in the atmosphere, I think it says there the level of, let's see, yeah, about 150 parts per million. Plants below 150 parts per million, there will be no plants in the world. It has to be more than 150 parts per million. But those bars there are 20 parts per million each apart. Along the bottom line, you can see it goes from 20 all the way up to 540. So in increments of 20 parts per million. So the first parts up to 150, up to 200, that is the greatest impact on the climate, the temperature. But every 20 you add after that, it has a very little impact on changing the climate, the temperature. So in fact, you'll see a chart later where I show you that even if we doubled how much carbon dioxide we have in the atmosphere from 420 to 840, it would have very little impact on changing the temperature. And this here shows that. Let's see if I can explain that. The smooth line above, the smooth line going from 0 to 1,000 or so, I think there. But that is if there is no greenhouse gas in the atmosphere at all. That's what the energy from the sun would cause on the Earth. And if there were no greenhouse gases, we would be at a temperature of about 16 degrees Fahrenheit. In other words, we couldn't live in that atmosphere. So we actually, the average in the world is somewhere between 55 and 60 degrees Fahrenheit. So without any greenhouse gases, you would, we wouldn't have life. But here it also shows the impact of carbon dioxide and the impact, well, methane is in the next chart. But if you look at the first, the raggedy curve underneath that smooth curve, you'll see at the dip there, that is at 0 carbon dioxide, and then at the green up, or sorry, the other way around. The green is 0, and then the red and blue down below is almost no difference. It doesn't depend. Adding more carbon dioxide has almost 0 impact on global warming. And the same is true for methane, same kind of a curve. These are scientists that determined that way back, long before we started looking at the climate. And the other impact you can see, all of the greenhouse gases, the biggest impact is by the water vapor and the clouds. And the carbon dioxide, yes, it is the next most significant one, but then methane is only 10% of the impact of carbon dioxide. Okay, so but here's the important one, the warming impact of C2. We are now at 420 parts per million, and you can see that we are up to, I think it was 88% of the temperature that we would reach if we maximized the amount of carbon dioxide in the atmosphere. So adding more carbon dioxide in the atmosphere makes almost no difference at this stage. So that's where we're at. Okay, this is a longer time frame. You won't remember, but if you read your history books, you'll see that there was a very minor ice age back in the 1600s, and that's where the red is, and you can see the dip. And then when there's more sunspots, you get more activity, and it warms up a bit. Now we are in that between 2000 and 2050 there. You can see we're in the downward curve. So at some point, we can expect that we're going to enter a cooling stage. And it'll take time, but I expect we will see that the next 10, 15 years. And even NASA made the prediction that solar cycle number 25, which is in the end of that chart there, that's not as high as the previous blue ones there. Okay, then another implication or a cause of global warming and cooling, the PDO, Pacific Decadal Oscillation, that's the oceans. And you'll see the effect here. In fact, you can see the blue there means that the oceans are cooling the world, and you'll see that happened between 1960 and 1970, 80. And then now we're in that last stage there where it's red, and so we in fact are warmer. So the ocean temperature impacts the temperature in our world significantly. Okay, issue number 7. You may have remembered that the UN IPC issued a Paris Climate Agreement, and they even determined that it would have almost no effect on the climate, even by 2100, if it were implemented by all the countries. So here's the work of the UN IPCC. It deals with greenhouse gas emissions and how we could mitigate that if we do something, or how do we adapt to it, and the dollars that it would cost to do that. So it was adopted by nations in 2015, and you will remember that Trump exited us from that agreement because he understands that this has no impact except for wealth transfer. Started in the countries who were to start that in 2020. Signed by 125 nations, ratified by 144. But the implementation, if we were to implement that, the implications are that it might change the temperature down by 0.306 degrees Fahrenheit by 2100 if we fully implemented that, but at a cost of up to $132 trillion. And every estimate of money is going to be double that next time you look at that number. So it just doesn't work. So the UN, and the reason why we're in this pickle, if you will, is they use models that are not realistic. I mean, scientists can come up with models, and if they choose the right parameters, they can predict the future. But here's the case of the models that the UN, different countries in the UN came up with. They all came up with different models, and you can see there's 102 different models represented by this. The average is in that big red line, but all these models, they're all up by 2020. 2030, it's up by a few degrees centigrade. But the actual measurements that people take are way down in the noise, the blue and the purple and the green. So the problem is their models are incorrect because they're making wrong assumptions. Okay. The other contributor to getting the wrong answers is that the way they determine the average temperature, they have temperature stations all over the world. Most of them are in Western countries and in Europe, and we have a lot in the U.S. But these weather stations that measure temperature, the environment where those stations are changes over time. What do I mean by that? We have what I call the urban heat island effect. In other words, if your temperature station is, when like the 1900s, early 1900s, you lived in a rural area, had a temperature station in a rural area, and then when the highways and the cement, increases around that temperature station, it measures a hotter temperature than it would in a rural. In fact, it can be off by a few degrees Fahrenheit or centigrade. So it depends which weather stations you use to determine what the average temperature is. That will give you a different answer. And here's one example, correlation of average temperature and the number of surface stations. So the average temperature is in the red, and then the number of stations is on those dots. So if you decrease the number of stations that you're using, and you are not using some of the ones that were in the rural area, you have more stations now in the urban area, you're going to get a hotter measurement. So, it's not a good experiment they're doing there. So now they're starting to use temperature measurements in the atmosphere up above the clouds, and those measurements are more accurate because you don't have the daily weather changing them at all. And so it's up in the atmosphere, but they've only been doing that since 1979, and you can see, it hasn't moved a whole lot till then. We have just gone through a peak, here in December, November, December of last year, and now it's coming back down again. So there is significant changes over time, but you have to understand why they're different. But this is a more accurate way of measuring average temperature. Another prediction made by Al Gore, the number of polar bears would become extinct. Well, when he made that, it was about 5,000. Now there's more than 25,000. So obviously that prediction didn't come true. Sea levels are supposed to rise by 7 feet or so by 2100. Well, that's not happening. It's only rising by a few millimeters per decade. So it's not per year. So it's not moving much at all. The blue line indicates the sea level average. That green line shows the amount of carbon dioxide in the atmosphere. So you see, as the carbon dioxide increases significantly, the temperature of the ocean doesn't really, or the level of the ocean doesn't change. Arctic sea ice is not disappearing. Here's a picture in 2012. Back then when Gore said that's Arctic ice is going to disappear. Well, here's a picture from 2013. It's in fact greater. So then we look at weather extremes. Are they increasing? Well, look at drought. You'll see the drought in the blue, and excess water in the red, and you'll see that again it goes through cycles. So it's always gone through cycles. Another one, people say, well, we have more hurricanes today than ever. Well, they can measure way back to 1880 here, count the number of hurricanes, and you'll see that the red line shows the average direction. Now, there's a big one in 2000 to 2009, but that's one, but there's no big change. Another one is the number of violent tornadoes. You can see there was a big one in 1974, but after that, they go all over. They're certainly not going up by a significant amount. Same thing with the cyclones, severe in the red and less severe in the yellow. So again, it's not getting bigger. And this is a very significant one. Some of you may remember back of course, we weren't alive in the Depression, but we remember that was also a very hot period back in the 30s, the dust storms and all that. The heat wave, there were significant heat waves, and now that has leveled back down. Yes, there are some big ups and downs, but nothing like the 1930s. And same thing with the percentage of days over 100 degrees Fahrenheit. The carbon dioxide is increasing. We're up to 420, but look at down there. The percentage of days over 100 degrees Fahrenheit are not very high. And, Now, here's one that you can relate to today. We had some severe fire in California. And so that must be the worst ever. Yes, it was a very bad one. But if you look back in history, going back to the 1900s, you burned a lot more acres. The forests weren't managed at all, and there's nobody there to monitor the fires or take care of them. But then over the years, you can see it's leveled off. And then in the modern period, the last 20, 30 years, you can see it's going up a bit. So the point is, how do you convince somebody that we have more dangerous fire and more acreage burned than ever before? Well, you're not going to show them that curve. Okay, you're going to show them this curve from 1980 to 2020. It shows this last part. Look at that. Look how much we better do something about it. But they forget about looking before that time. It really wasn't much worse then. So it's not the carbon dioxide that's causing that in the atmosphere. And same thing with the ice coverage up in the Arctic. You can measure the number of acres covered by ice in the Arctic, and people would say, well, it's going down. Well, at certain times of the year, yes, it does go down, but if this shows the amount of acreage from around 2000 to maybe 2022 there. They all follow the same curve. All those lines, they're different years, and they all, within a very small range. So that's not an issue. This is the disasters, climate disasters, weather disasters. And the number here, U.S. weather and climate disasters from 1990 to 2020 or so. You'll see there's some bad years, but in general, the trend is, pretty level, not much difference. There are some exceptions, of course, but it's not a whole lot. So why do we have it wrong? Well, this is one reason. The UN IPCC Charter limits the research to identifying only human causes of global warming. Remember, the biggest cause of global warming of the temperature on the Earth is water vapor and clouds. We don't control that. Okay, here's what the charter says, the IPCC. It says from the outset, we are to assess on a comprehensive, objective, open, transparent basis the scientific, technical, and socioeconomical information relevant to understanding the scientific basis of risk of human-induced climate change. So that's why they don't include water vapor and clouds in their study, because we don't control that. And yet that is the biggest determinant of the weather changes or climate change. So then the other thing here is they have admitted that their real agenda is not to control weather, but is to redistribute wealth. One official even had this to say: we, the UN IPC, redistribute de facto the world's wealth by climate policy. One has to free oneself from the illusion that international climate policy is environmental policy. This has almost nothing to do with our environmental policy anymore. This is from one of the UN officials. So they admit that's what their goal is. It's not to, mitigate or adapt to the weather. You can relate to this. Imagine, if you will, a world where people believe that the temperature of the planet can be controlled by giving more money to the government. So then the last issue here is these people in the UN, they say, we have a large consensus. There are 97% of the scientists say that the world is warming, and it's all because of carbon dioxide. 97% of scientists say that. Well, how do they come up with that? They look, here's number of scientists that were surveyed, the number of surveys that were received back from them, and then the small number of climate scientists, that, in other words, researchers in climate science, like in the UN, and whether they agreed to a statement or not. So that's what the 75 over 77 gives you the 97%. And there are about 5 different surveys that have been done, they're totally different surveys. They all come up with 97. How can that be? But then, so they ignore all the other response. So that's bogus. Okay, so that's the bad news. The good news, there are in fact benefits of warming and adding carbon dioxide to the atmosphere. And I'll go through a few of them. We actually have fewer natural disasters and disaster deaths when we have more carbon dioxide in the atmosphere. Global warming actually saves lives. There's fewer droughts, reduced wildfires, increased food production, a greener planet, reduced extinctions, and adaptation rather than mitigation is much, much less expensive. So here, the annual death rate from natural disasters, has been decreasing over time significantly, but we're adding carbon dioxide to the atmosphere all this time. And here is a number associated with the climate-related deaths over this period of time from 1920 to 2020, for 100 years. You can see that the number of deaths due to disasters is much, much lower than it used to be. And here's another one. We have more people dying from the cold weather than from hot weather. On the left, you'll see a chart, which the blue is the number of deaths from cold, and red is the number of deaths from heat. But what's deceiving about that is that these scales are different. On the left here, the scale goes from 0 to 250, and on the right, it goes from 0 to 40. So it makes it look like, it's different scales. But if you put it on the same scale, you get the chart on the right. So many more on the same scale, many more people die from cold than from heat. So we shouldn't worry about warming up a few degrees. We have seen increasing precipitation, which is good for food growth. C2 as plant food works. Plants, they need more CO2. And then corn yield, bushels per acre, has actually grown over time. And part of that is, the warmer weather, more carbon dioxide, and of course, better fertilizer too. And this one shows it here. The small chart here, the red shows the corn production has gone over time from 1850 to 2010. So the corn production has grown, but the number of acres used has stayed about the same. So it's much more productive today with warmer, with more carbon dioxide in the atmosphere. And here's that chart I showed you before. We're from 385 parts per million to 835 parts per million. The plants grow much, much faster and not bigger. We have an increased growing. You can plant your garden earlier and then benefit from it later. So the world is greener than it ever has been, and this shows it here. It goes in percentages here. From the darker is 30%, and the light green is 0, and so no change, and the red is less. So the greener the world is, the more food we can have to feed people. So it helps to have more CO2 in the atmosphere. So in this chart, it's kind of hard to see, but basically it shows the changes in carbon dioxide is the red curve, and like the parts per million goes from 1,800 to 2,000 has grown significantly, and there's more emissions per capita in the other chart. The life expectancy has increased, and then per capita GDP has also increased, and the population has increased. So with more carbon dioxide in the atmosphere, we're better off. So what do the experts say? Okay, there's a coalition called the CO2 Coalition formed about 10 years ago, established for the purpose of educating thought leaders and policymakers and the public about the important contribution made by carbon dioxide to our lives. And here are some of the scientists that I use as my witnesses, if you will. I agree with them. Many of them are physicists as well, and I agree with their results. One that stands out that I've underlined is John Clauser. He's got a PhD in physics, and he earned a Nobel Prize in physics in the year 2022. And he calls global warming, climate change is a hoax. He uses very strong words because he is some of those charts I showed come from his work, and they clearly show that we are not in any danger, and we're living in a healthier environment the more carbon dioxide we have in the atmosphere. So, and these are some others, and I'm not going to go through all of these here. William Happer is another one that I follow, and he shows increased levels of carbon dioxide, nitrous oxide, and methane. It will not escape, we will not escape, we will not cause a climate emergency. This is another extraordinary popular delusion and madness of crowds in the sad history of human lust for money and power and folly and cowardice. He has been an advisor to President Trump, and so we hope he's going to impact the direction that we're going here. So they're pretty strong words, and the results back them up. Okay, I'm just going to, in the interest of time, I'm going to step through some of these, but they have a similar kind of thing. They're very strong that hey, we don't have a crisis, we don't have a climate crisis. And the worst thing, I'm not going to cover this here, but there's two choices we have. If we have a real climate crisis, there's two things we can do. We can either adapt to it which doesn't cost a lot, or we can mitigate it. In other words, you can do things like carbon capture storage, take carbon dioxide out of the atmosphere and bury it in the ground. Now, that goes counterproductive, counter to what we were saying, because it said the more carbon dioxide in the atmosphere, the greener Earth we're going to have. So that's not very helpful.
Isn't that what Bill Gates is doing?
And so these are all, scientists that I agree with, obviously. Here's Steve Koonin. He was a past president's cabinet on the EPA. So he has changed his mind too. He says we do not have a climate change issue. He was in Obama's cabinet. So here's what we see, our use of coal, oil, and gas. And why are they used? They're used to produce electricity. Electricity is what makes our life possible. If we didn't have electricity, we would not have a comfortable life. The problem that people in Africa have, they don't have enough electricity. And so the elite want them, not to use the gas, the oil, and the coal to produce electricity. So they suffer because of that policy. So here we're increasing the use of all these three. We're now at 2025, and the target was to get to net zero by 2050. You think we're going to make it? I don't think so. You'd have to stop a lot of things to make that happen. So that's just, it's impossible to reach that. So in conclusion then, the UN IPCC models have failed miserably. They just don't project the future, and they can't even be back-tested against the past. They don't work, period. So if I'm a scientist, if my theory is wrong, I'll change my theory, to match what we observe, but they don't do that. Sea levels are not an issue. Man-made causes are insufficient. The carbon dioxide and the methane components of the greenhouse gases have very little effect where we are now on our climate, and we shouldn't try to be taking them out of the atmosphere. Natural causes of climate change are more credible. The sun energy alone is not sufficient. Cosmic radiance with sunspots, that gets into the clouds, and clouds are a significant controller of our future. And then also the ocean oscillations control the temperature much more than the carbon dioxide does. So, and I mentioned the Paris Climate Agreement. I don't consider that a solution because we don't have that problem that they state. And to implement that solution, a non-working solution, would cost trillions of dollars for no gain at all. So, and then we saw benefits of a little bit more warming, and more carbon dioxide in the atmosphere is actually good for us. So what the news media doesn't tell you, I call it the mainstream media, global warming from 1978 to 1998, it was pretty level. If you look at some of those curves, it wasn't increasing a lot. Lately, it has been increasing a little faster, but it's also come back down. And we expect to see some global cooling in the near future. The Antarctic ice sheet is growing, not melting. Same with the Arctic ice. Sea level is rising 7 inches per century, not 20 feet as some IPC members said it would. As more we have some snowfall records set in the past 10 years, not here, but in other places. CO2 and methane cannot cause much global warming. I mean, they've caused as much as they can possibly do. Like CO2, that one chart, it's up to 88% of how much it could produce. Even if you were to double it or triple it, it's not going to make much difference. So clouds, sun cycles, ocean currents, volcanoes, all natural causes, they can and do control climate change. It's not the CO2 and the methane. It's all mostly the natural. You know, CO2 does cause some warming, methane does some warming, but not like the alarmists say it does. So severe storms are not more frequent than normal, and yet that's what you're told all the time. You get the next storm, the next heat wave, it's always the worst. And that's just not so. So in closing then, what should the church do about global warming, climate change? We should commit to viewing the world from God's perspective, and I covered that in the biblical mandate in the first few slides. We should follow that. And we need to understand and rely on Scripture as a foundation for life. And I use that one verse, Genesis 8:22. We will always have seasons. That God promised that forever. And we should help inform other believers on the truth of what's really happening out there and promote the truth, oppose false beliefs with gentleness and respect. And so with that, I bring this to an end. Thank you for your time. And anybody disagree? But anyway, we'll take a few questions if we...
I have a question.
Yeah.
How do you determine the temperature like in 1900 and 500 AD? I mean, how do you know, how do you plot that?
Well, that's from looking at like ice cores and tree rings. They can tell, not very accurately, but they can tell the trends. And of course, we know from history, the medieval age, when Greenland was green and is not green now, right? So we know there was this change. Yeah.
Okay, good. Questions?
Wait, is it on? Yeah, okay. So when the children of Israel came into the Promised Land, it was supposed to be milk and honey. And like when Mark Twain went there, he says, nothing's there. It's desolate. So it must have been a huge climate change. Egypt used to be a rich land with...
From what? Could you explain? I didn't catch it.
When the children of Israel came into the Promised Land, it was supposed to be milk and honey. And then in Mark Twain's...
And of course, that was more than 3,000 years ago.
Right, yeah, and the Earth's changed so much.
Yeah.
Yeah.
Well, there has not been a big change over, I would say, 4,000 years, 5,000 years. We're talking about a few degrees centigrade over that time, up and down. But there's cycles, but there's nothing real like dropping 10 degrees or like that.
And I know the Bible talked about, was it Babylon, how nothing was going to be there anymore. And it's true, it's a desolate land.
Yeah.
But at one time, it was lush.
Yeah. And like North Africa, sometimes there was green, better, more productive grains produced there, but now it's, there's deserts. The range of the desert has changed over time. Yeah. But North Africa now is greener than it has been for a long time.
And I think the weather's getting better here.
Amen. We have a storm outside.
Sorry. I saw a thing. I was wondering if this plays into it, where the tilt of the world's axis changes the weather patterns so that every 1,500 years or so, like the summer will move into where winter is now over a long period of time. So like the tilt of the axis will change the seasons to being more in December, and then the winter being in July, but just because of the way that the Earth. Have you heard that?
Yeah, I don't think the seasons have changed that much over.
Yeah.
Yeah.
Oh, sorry. It was a video I watched, so I was curious if it.
Not as drastically as she's saying, but like fall comes weeks earlier than
Yeah.
it used to.
Yeah,
and-
yeah.
And that sort of thing.
Yeah,
Yeah,
it was
that-
just a video where like the tilt of the axis over a large period of time, like 2,000 to 3,000 years,
Yeah.
it'll change the order, like the seasons move slowly into a later or a different pattern.
Yeah,
But yeah,
the-
yeah,
Well, like I was saying, now the growing season is longer than it used to be because the earth is greener than it used to be. But that doesn't move the whole summer season.
yeah.
Y-
So it was a video I saw once. I just knew if you knew about it.
Yeah.
Yes.
So I've seen a couple videos recently where there's a couple different places where they're shooting rockets into the air to create rain clouds.
Yeah.
And if moisture and vapor in the air is a huge factor of climate change, wouldn't that be considered man-created
Yeah. Yeah.
altering?
Yeah. Well,
Atmosphere change?
You're talking about geoengineering,
Yeah.
right? You heard that term. They're trying to seed the clouds to
Yeah.
produce rain, and yes, that does happen. Unfortunately, we shouldn't be messing with that, is my opinion, but it is happening, and that doesn't solve the problem.
Nope.
It could create more problems.
Yeah. Yes.
What is your opinion on renewable energies, such as water energy, solar energy? It's because some people might say this might be a better solution for climate change. What is your opinion on that?
I don't think I caught your.
Oh, sorry.
Yeah.
I'm still learning. What is your opinion about renewable energy?
Oh, okay. Yeah, because renewable energy, like electric cars, they want to change they want us to be dependent on electricity. That's why electrical cars. But to get there, you need to use oil and gas to build them in the first place. And renewable energy, like using solar farms and wind farms, that is not working very well. I mean, you may have heard in Texas a few years ago, they had a severe winter, and they depended on the solar power, but the solar was covered by snow, so it wasn't producing any. And the wind farms are a problem because they can be so destructive. Birds run into them and get killed. Whales are getting killed in the ocean when you build them in the ocean. So it's very destructive. And the problem, if you were to think you can depend on solar energy and wind energy, then if you have a severe condition, you need some backup power. And that can only come from reliably from carbon dioxide fuels. So it's a problem. And it's a very expensive solution, and it doesn't solve all the problems. Yeah. See, and because like people in Africa, that they don't have the money to build, these power plants to produce what they need, and the elite doesn't want them to be building stuff, that depend on fossil fuels, and yet, we are dependent on fossil fuels. There are about 6,000 products that depend on fossil fuels. And so you'd have to do without a lot of things that you enjoy today.
So we're constantly being told that CO2 is bad,
Yeah.
right?
Well,
And you're saying it's not.
Yeah. Well, the newspapers would say it's a pollutant, but it's not. Life depends on CO2.
Oh, very good.
Yeah.
Other questions? Yes.
Hello. So it's not exactly renewable energy, but you're an experimental nuclear physicist. What are your opinions about molten salt reactors?
I mean, using reactors as a source of
Yeah,
power.
in place of the fossil fuels.
Yeah, nuclear reactor power is very economical, to produce wattage. It's one of the cheapest ones, and it is really pretty safe, if we handle that properly. So that is one of the cheapest sources and the safest sources. And, countries like France, they're very dependent on, nuclear reactors, whereas Germany has gone exactly the other way. And you can see the results of cost of electricity is very large.
Okay. So Heinz, would you close in prayer for us?
Yeah. Yeah, and I'll be available if you have other questions you want to ask, just come on by. And my website is there, heinzlycklama.com. This lecture will be up there. Well, my slides are up there now on my website, not right there, but I will send you a link to where they can be found. And so you can download the slides. I showed you only half of the slides that I had based on the time available, because I've been studying this for many years, and I'm pretty confident that I'll have the right answer, given that all these physicists, they agree with that. So anyway, let me close in prayer. Father, we just come to you again this evening just to thank you for this time. Thank you for each person that's here. Pray that each one will have learned something new. And if they have questions, Lord, let them ask questions and to come to the truth, Lord. And we just pray that many people here have learned something new that they can share with their family, friends, colleagues, what have you. And we just thank you that you have given us the ability to study your creation, Lord, and to find out how it works. We don't have all the answers, but we can continue to research, because you have given us the ability to do that, and we thank you for that. I just ask you now just to bless the results of this meeting. In Jesus' name we pray. Amen. Thank you. Learn something new.
Yeah, I like the charts.
Yeah.
The lighting in here, it's hard for me to not get drowsy from the bright lights.
Yeah.
I have a question. You were talking earlier about how it's like there's a threshold that carbon dioxide can actually affect things. Like it gets to a certain point and it just stops heating up. I think it's like 87 or 88% of its capacity.
Yeah, we had 422 parts per million. You saw that curve that goes exponentially down. So we're now at 420, and the next 20 parts per million will add just a little bit to
So
how
if we
much
had
it-
like, let's say like 500,000 parts per million, it wouldn't get it.